In this video, we're going to talk about measures of variation. Measures of variation talk about the spread of the data. How far is that data spread out in its entirety between the minimum and the maximum, and how far are the individual data values spread out from the mean? So let me scroll down here to the portion of our worksheet that goes through measures of variation. Okay, so here we are. So these are also measures of spread. So I want to start by using this distribution of ages to find some of these measures. Starting with the range. The range is the maximum minus the minimum. So I'm going to take that maximum of 32 and subtract the minimum of 16. So pretty straightforward. 32 minus 16 is 16. So I've got a total of 16 years between the youngest person in this group and the oldest person in this group. The mid-range is really the same formula as our midpoint. So I'm looking for the midpoint of the range. It's different than the median. The median uses the actual data that's in the middle. The midpoint just uses the max and the min and finds the midpoint of that range. So I'm going to take low minus high. So 16, finding this midpoint, plus 32 divided by 2. It's going to be what, 48 divided by 2. So we get a mid-range or midpoint of 24. This one is also a measure of center, right? It is giving me an idea of what the center would be if the ages were perfectly evenly spread out throughout the range of 16. Next is the sample standard deviation. So we do have formulas for those, and I've got those covered in a different video. But the sample standard deviation, we use this one when we're doing inferential statistics. That means that we're using this sample standard deviation, S, to approximate the spread of data for a different or larger group. So our sample may not have the extremes in it, right? I may not have the youngest person and I may not have the oldest person, but a different or larger sample is likely to have one or both of those. So the inferential version, this sample standard deviation S, is used to draw a conclusion about a different or larger group. So it's a little bit bigger to approximate the spread. The population standard deviation, however, is used for descriptive statistics. We denote this with the lowercase sigma, and this one is used when we're just talking about the spread of the data set that we are looking at. So we're considering that the entire population. More typically, we use the sample standard deviation because a lot of stats is using the data we have, which isn't usually all of it, and drawing some conclusions based off of that. Okay, so to find these two, I'm going to use Google Sheets. So let me go to, here we are. So let me just go ahead and grab my Google Sheets. And I want that age data. So I've got the age data here. To calculate this, I'm going to go ahead and grab an empty cell, and then I want to use a formula. So I do equals, and I'm looking for a standard deviation. So it's STDEV for my standard deviation. And you could do .s, and a lot of times the values will pop up here. Turn on formula preview. Okay, so stdev.s, or you can just use stdev. I'm going to go ahead and grab those values and then hit enter. And this gives me the sample standard deviation. So this one is S. If I want the population standard deviation, I'm going to go equals STDEV, and I want the population one. So this one is .p. And again, a lot of times they pop up for you. So this is going to be all of these values here. Enter. Notice how this one is sigma. I'm just going to type sigma population standard deviation. So notice how S is a little bit bigger because we use it to approximate the spread of a different or larger group. Okay, so the other nice thing about Google Sheets or Excel, they work the same. You can do your rounding. You can probably round on your own, but if I go ahead and choose this one, say I wanted to round to 2 or 3 decimal places, I'm just going to grab off of my toolbar the decrease decimal places. And I just start clicking until I've got my 2 decimal places. And then I can do the same with this one. I mean, again, you can just eyeball these, right? So 4.78 and 4.62. So let's go ahead and write those up here. So 4.78 and 4.62. There we go. 4.78 and 4.62. Okay, so that's our standard deviation. Do not calculate this by hand. There's just too many great ways that we can do this using Google Sheets. I'm also going to show you later in the video how to use Desmos or your calculator. We want to compute the table now using the population standard deviations. We want to know how many of our ages are within one standard deviation of the mean. That's what the standard deviation tells us. It's the typical distance from the mean. So I'm going to draw just a number line up here, and we're going to put our mean in the middle. Let's go ahead and grab our mean. So mean. Excel and Google Sheets does not use the word mean, it uses average. So average, and then I want to grab all of my data and then enter 21.4. So I want to know how many data values are within one standard deviation of 21.4. So I'm going to go ahead and put 21.4 here. Standard deviation is distance from the mean. So we can say that one is 0 standard deviations away. We want to do 1, 2, and 3 standard deviations away. So 1, 2, and 3 standard deviations away. We're going to do it positive and negative. -1, -2, -3. So within means plus or minus 1 standard deviation. So to get to these, what I really need to do is just add my standard deviation. It's asking me for sigma, so I'm going to go ahead and grab my 4.62. So I'm going to do plus 4.62, and I can do that here in Google Sheets. So equals 21.4 plus 4.62. And I end up with 26.02. So 26.02. And if I subtract it, so equals 21.4 minus 4.62, I get the lower end of this range. Oh, let's see. Equals, let me try that again, 21.4 minus 4.62. There we go, 16.78. So 16.78. 16.78 is what that says to 26.02. That's my range of values. These are within one standard deviation of the mean. So 1 standard deviation of the mean. This is a typical distance from the mean. So I should have the majority of my values within these numbers. So let's find out. Between 16.78, so I need to start at 17, but I can include 26. So that's going to be from here to, I can include 26 to here. Let's count that. So equals, count, parentheses, 17 to 26 is within one standard deviation. Notice how that's the majority, and we get 12. And this is within one standard deviation. And this is for the population. Okay, so we get 12 values. We also wanted to find the percentage. So I'm just going to do that right here. There are 15 values total. If you forgot n, I'm going to do a count over here. So equals count parentheses. You're never going to have to count again. I don't know if I can see all of that. Nope, I need one more. Okay, so equals count 15. So to find the percentage, it would be equals 12 divided by 15, and we get 80%. Okay, 80% within, so 12, 80%. Let's go ahead and put that here. So 12 and 80%. Whoops, no. Pen, so 12. And 12/15, which is 80%. Okay, so next I went within 2 standard deviations. So I need to just add another 4.62 and subtract another 4.62. There's a bunch of ways that you could do this, right? I happen to be using Excel here or Google Sheets. So I'm just going to go equals 26.02 was 1 away. Oh, actually, let's do it this way. I'm going to take my mean, 21.4, and I'm going to add 2 standard deviations, 2 times 4.62. You could also just add another 4.62. We get 30.64. Let's do the same with subtracting. So equals 21.4 minus 2 of my standard deviations, 4.62, 12.16. So I get 12.16, 2. Oh, let's see. If I do this one, I think I can do it. There we go. 30.64. Okay, 30.64. Within 2 standard deviations, I have even more of my range. So within 2, let me grab a different color highlighter. I'll use this one here. Within 2 standard deviations, 1 is a typical distance from the mean. So within 2 standard deviations, I'm including even more. So I don't have anybody as young as 12.16, but I do have somebody at 32. So I want to go ahead and take these and let's go ahead and do our count. So I want to do equals count almost everybody, right? I mean, I can see it's going to be 14 of them. Highlight everybody but 32, and this is within 2 standard deviations. I can also do my percentage here, equals 14 divided by 15. You can do all this with your calculator too. To get within 3 standard deviations, I'm going to do the same thing that I did up here. So equals 21.4 plus 3 times 4.62 equals, and I'll do the same thing down here, 21.4, but minus 3 times 4.62. I must have forgot my equals. So easy to do. Equals. Okay. 7.54. So within 3 standard deviations, I have a much smaller group. So this is 7.54. Oh, whoops. So 7.54. And now my upper end is 35.26. This is everybody. So 14 was here, 15 is here. This is 100%. And when we did 14, that was 93. What was that? 93.3%, almost all. 93.3. So a little bit tedious, but it's a great representation of what that standard deviation means. Most of my scores, most of them in this case means 80% are within that typical distance from the mean, that standard deviation of 4.62. Nearly all, so this is within 1 standard deviation. Nearly all, 93.3%, were within 2 standard deviations, plus or minus 2. And then all of them for this case were within 3 standard deviations. Standard deviations are used a lot in the medical field. So if, for example, you get your cholesterol checked and they tell you that your cholesterol level is high, that means that you are more than 2 standard deviations or maybe even 3 standard deviations. They would expect a normal to be within 1 standard deviation. So those standard deviations show up a lot. Okay, question number 2. We want to use the exam data to find some measures of variation, and then we're going to do the same analysis with the standard deviations that we did in the last example. For this one, though, I'm going to go ahead and use Desmos so that you get another example of technology that you can use. I'm going to use Desmos to find the minimum and maximum and our standard deviations. So let's go over to our exam scores. I've already copied and pasted them into, I'm just going to make this big for a minute. I already copied and pasted them into a Google spreadsheet. They show up this way, but I want them to be in a column because Desmos doesn't like them in a row. So I want to go Edit Cut. You could also do Control X. And then I'm going to grab a just a blank cell, and I'm going to go edit, paste special, paste transposed. So there are my data values. I'm going to copy them, edit copy, and let's go to Desmos. I'm just going to type in DESMOS, free calculator and graphing tool. So in Desmos, we don't care about the graph today. We're just going to be using the calculations. So I'm just going to click on an empty cell. These are exam scores. So I'm just going to call them S for scores. So S equals, it's great to name it. And then I'm going to do a Control V to paste, Control V. So there's my 15 element list. I want to find the maximum and the minimum and my standard deviations. So keypad functions stats. So I've got the maximum and the minimum. This is especially helpful if you have a huge data set. You'll notice that we also have standard deviations. This STDEV is for the sample, and then there's the P for the population version. So let's go ahead and do that. So I'm going to go, you don't need to hit equals here. So I want to find the max of data set A, enter. Whoops, data set S, enter. There we go, 98. Let me get rid of that guy. Okay, maximum of S. And I also want to find the minimum. I remember it's MIN. I can just type it in, parentheses S. So there's my minimum. To find the range, I can go 98 minus 62 right here. So there's my range of 36. To find the mid-range, just using this like a calculator, I'm going to go parentheses 98 plus midpoint, mid-range, plus 62 divided by, so slash 2. So that gives me my midpoint formula and my mid-range of 80. So 36 is my range, 80 is my mid-range. We can also find our standard deviations here. Notice how it's a little bit cleaner because I've named that. It's a little cleaner than Google Sheets. So I want to find the sample standard deviation. So I'm just going to go functions, stats, standard deviation. It says of what set. I'll do it correctly this time, S. And I remember that the standard deviation for the population, STDEV with a P at the end, parentheses. And then I want S. So I've got all of my measures here. Let me minimize this and we'll copy these values over. So Desmos is a great way to do these calculations. Notice just how quick that was, right? So if I put these all in here, there we go. Okay, so our range was, I need to just scroll up a little bit here. Our range was 36. Okay, so our range was 36. Mid-range was that midpoint, which was 80. Sample standard deviation, we're going to call that 11.9. Watch the decimal places. If you're doing intermediate calculations, which we aren't yet, but we will be, you're going to want to keep more decimal places. And I'm going to call that next one 11.5. Whoops. 11.5. And we want to do the same analysis that we had done before. So we also need the mean. The standard deviation is the distance from the mean. So back in Desmos, if I go to functions and then stats, you'll notice that the mean is the mean here. So I can go ahead and click on mean and then hit S. You could have also typed this. We're going to call that 82.1. So our mean is 82.1. Let's go ahead and do this analysis now. So for our range of values, we want within one standard deviation. So within one standard deviation, it's going to be my mean. I can do this here again. So I'm just going to start. So this is 82.1, 0 standard deviations away. 1 standard deviation above, 1 standard deviation below. So I just want to add and subtract 11.5. We're going to use the population one. So this is equal to 82.1 minus 11.5. It's going to be the lower range. Oh, and I put equals because of Google Sheets. You don't need the equals. It's like a calculator. Okay, so 70.6. And then for the upper one, I'm going to do the same thing. 82.1 plus 11.5, 93.6. So 70.6 to 93.6. So 70.6 to 93.6. And then we can continue to do our analysis here. Let's also do the next one. So 82.1 plus, we're going to do 2 times 11.5. And then 82.1 plus 2 times, I need to change that to a minus, don't I? Minus 11.5. So I've got between 59.1 and 105.1. So 59.1 and 105.1. And then finally, I want to do 3 standard deviations. I can edit what I did in these upper calculations. So instead of 2 standard deviations, we're going to change that to 3. Okay, and so for the last range, the biggest one, 47.6 to 116.6. Now we need to find how many are within each of my ranges. I'm not going to be able to do that here because this data, is it in order? I think it is in order, actually. It is in order, but Google Sheets has that count feature. So you can just count them up. It's not that big of a data set, but just such a good exercise to use that count feature again. So let's do it. So I've got my data here. I want the values between 70.6 and 93.6. So I'm going to go equals count 70.6. So I can go to 71. I could go up to 94, I mean to 93, and I do have 93s there. Enter. Oh, 0. Whoops. Okay, so equals count. I just grabbed okay, 71 to 93. There we go. 10. This is within 1. And then within 2 equals count 59.1. So I can go to 62. 105, that's everybody. Everybody. So 100% within 2. So I know it's going to be 100% within 3. Within 3. Okay, this is, so if I want the percentage, it's going to equal 10 divided by 15. 66.7. Okay, so let's go ahead and complete our table. 10, right? Most of our data values are within 1 standard deviation of the mean. That's a typical distance from the mean. 66.7. All of them were within 2 standard deviations and therefore within 3 standard deviations. So 100%, 100%. Okay, so that is number 2. Let's take a look at number 3. So for number 3, we have a grouped frequency distribution. We want to start by finding the midpoints, and then we're going to move on into the weighted mean, modal class, and standard deviations. Let me go back to my blue pen here. So to find the midpoint, we want to take the lower value plus the upper value for the class and divide by 2. That's 14 divided by 2, or 7. And you'll notice as we move from lower limit to upper limit, we have a class width of 5. So class width equals 5. So I can go ahead and add 5 to get to each of those midpoints, or you could calculate each of them. To do the weighted mean, we need the calculator. So I'm going to put my midpoints and frequencies into the calculator. Clear this. So let's go ahead and go into Stat and then Edit to enter data. I've got a bunch of data here. I want to clear it. So up to the list name. So all my values are at the bottom there. I hit clear and enter. I also want to get rid of L2 here. So up to the list name, clear, and then enter. So let's just enter these values, 7, 12, and 7. So I actually have, whoops, and 7. So I actually have 12 values represented by the midpoint 7. So it'd be like 7, 7, 7, 7, 7, 12 times. Got a bunch of values represented at 12 also. There's just 2 of them, 12, 12. And then there are 6 17s. So I'm going to use the frequencies instead of listing all of those midpoints out individually. So I've got 12 of the 7s. I've got 2 of the 12s in my list and 6 of the 17s. Let's go ahead and calculate one variable statistics. So second quit, stat, calc. I choose one variable stats. If your calculator looks different than mine at this step, just hang on a second and I will show you what yours is going to look like. If yours looks like mine, list is where your data is. Those are my midpoints. They're in L1. Frequencies, I put those in L2. So second 2 to grab L2, and then I'll calculate. So I've got my my mean, which is the weighted mean of 7.5. Let me make sure I put my data in there correctly. And then I've got my standard deviations as well. Let me go to stat. I'm going to check my data, enter 712. Oh, I thought that looked low, 17. So good for if you caught that one. I want a 17 there. Let's do it one more time. So stat, calc, one variable stats, L1, L2, they're already there for me, and then enter. There we go. So 10.5 is my weighted mean. 10.5. My modal class, I don't need the calculator for that. That's the one with the highest frequency. So that's going to be the class 5 to 9. Nice review. And then I want my standard deviations. My standard deviations are going to come off of the calculator. Now, if your calculator didn't prompt you for the list and frequency list, yours would have looked like this. So if I go second enter, I'm going to back up just a second, and yours would have looked like this, right? It just put one variable stats, maybe it had ONE spelled out. So it's just waiting to see where your data is and your frequency list. So I'm going to go second L1, that's where my data is, comma above the 7, second L2, that's where my frequencies are, and then I hit enter. So it gives me the same values. S is my sample standard deviation. We're going to call that 4.6. So 4.6 goes here. And then my population standard deviation, so this one is S. My population standard deviation is sigma. Notice how it's slightly smaller, representing just this data. That's going to be 4.5. Unfortunately, Desmos and Google Sheets or Excel they just don't do a great job with frequency distributions. So the calculator is the best way to go here, using midpoints and frequencies. So you've got so many tools available to you, the calculator, Desmos, and Google Sheets. I want you to use whichever one is the easiest for you, and maybe whichever one makes the most sense for data. If your data is really easy to copy and paste, use Google Sheets or Desmos to do your calculations. If it isn't and it's a small data set, or if you've got frequencies, go ahead and use your one variable stats in the calculator.